Alright, so let's pick up where we left off discussing the basic science behind AGW, enhanced global warming due to human effects over the past century and a half. What we want to do in this tutorial is take a look at the major factors that directly affect climate, and those are called forcings. Okay, so you need to know that term, and there are only a handful of those. And then to complicate things a little bit more, but they're very, very important, is we want to look at what are called feedback mechanisms. Mechanisms that enhance forcings because of temperature changes. Okay, and we'll explain that more, and then we'll finish up by looking at why we would care. What's the effects of AGW over the long term? Okay, so let's start with the forcings. We're going to break them down into two broad categories. All right, fairly simple, either natural. Okay, that's something that's out of our control. And then there's anthropogenic, which speaks for itself. Okay, so we'll label them N and A. Alright, so let's go with the one that gets the most news, okay? So what we're basically looking at is what physical factors affect how much sunlight reaches the Earth and how much gets away. Okay, that's where really it boils down. Energy input and energy output. Okay, so the whole anthropogenic is built around the idea of the greenhouse effect, which we mentioned in class. Right, we've already seen that there's a natural greenhouse effect that keeps our Earth much warmer than it would otherwise be, but we're going to look at the anthropogenic side of things, and this is a major type of forcing. Okay, so the greenhouse effect due to greenhouse gases are any molecules in the atmosphere that actually have more than 3 atoms. So these are the main culprits, right? And generally some oxides of nitrogen. What are not greenhouse gases, and this is important to understand, are the main constituents of the atmosphere: O2 and N2. So these are roughly 1% of what's left over, but they can have a large effect. A good analogy is your body is almost all water, but trace amounts of certain poisons or chemicals can do profound damage. So whereas these are, especially CO2 and H2O, have been largely beneficial to the Earth, we're going to look at our contributions, not so much as H2O. We have not affected water vapor in the atmosphere over the past century simply because of the water cycle precipitates them out constantly, but rather the major increase in CO2 in our atmosphere. I'll show you a slide tomorrow that shows how we've basically exponentially increased the concentration of CO2, especially over the past 50 years. Okay. The next effect is probably the most obvious, and that is solar radiation. Okay, if you want to understand any changes in the Earth's temperature, this would be the place to start. So of course this is natural. So in terms of AGW, we have found that this to be a minor to a moderate effect. Okay. We've established that the sun over the past century goes through short-term cycles, generally on 11 years. That's associated with the sunspots. We've been monitoring this very, very closely for about 3 or so decades. Okay, there might be longer cycles associated with the sun, but there's nothing that is obvious. But the big picture is the output of the sun has been stable, very stable, for centuries now. Okay, so put the short-term cycles aside, we see absolutely no evidence that changes in the sun are contributing to any warming on the Earth. There might be a small amount, but it does not match up with the temperature record very well, especially in the last 20 years. Again, I'll show you a video on that, or excuse me, a slide on that tomorrow. Okay. Another thing associated with input that's a little more subtle are orbital changes. Okay. The most obvious orbital change is our inclination towards the sun for the seasons. Okay, that's not really changing. That is not contributing to any increase in global warming. We get warm in the summer, we get cool in the winter in the northern hemisphere. Okay, but what we're talking about are subtle little changes in a distance from us to the sun because of the way the Earth spins. It's an angular momentum idea, like a precessing top, but essentially our tilt towards the sun is not always 23.5 degrees. It changes slowly over time. In fact, there's something called the 23,000-year Milankovitch cycle. We don't fully understand it, but we have very, very solid evidence about the subtle changes over this 23-year period that leads to the ice ages. Okay, so this is the reason why the Earth has been and most likely will enter another ice age. Okay, it happens over a very, very slow period of time, so it's a fairly minor effect that can have huge consequences, but we're talking about rates much, much lower than what we see over the past century. So the, if you will, natural cooling and warming associated with the ice ages and the coming and going are associated with this, but that's much, much slower than what we've seen. Okay, and we believe we're heading to another ice age that may peak in roughly 80,000 years. We're not quite sure when it's about to start because of our contributions complicate things. So we can rule out changes in our climate because of solar. It's been fairly stable. The orbital changes that occur to the Earth, over which we have absolutely no control, are too slow to explain anything that's happened over the past century. Okay, so the last factor is probably the least obvious, and it's a new term for us, and that is called albedo. Okay, albedo given a symbol alpha, and it's basically a measure of how much radiation from the sun is reflected, in other words, not absorbed by the Earth. This is both an A, we can affect it, and natural. All right, and it is a moderate to major influence. Okay, so simply put, higher albedo means more reflection of the sunlight. In other words, we absorb less, and lower value means we absorb more, and that's usually a warming effect. Okay, so higher value is warming, and lower value is a cooling. I mean, if we reflect more sunlight, it's less for us to absorb. All right, so what are some things that have changed over the century that might affect albedo? Okay, of course, there's ice and snow. All right, ice and snow being very, very white, that means that they reflect a lot of sunlight, so that is a strong cooling effect. Okay, if we were to increase the reflectivity of the Earth somehow, we would reflect more sunlight. That could offset climate change, and people have actually proposed something like that to mitigate it. More difficult to measure are clouds and contrails, which left behind by airplanes and whatnot. These reflect sunlight. The problem with studying these is they're very short in time span and short in spatial, so it's very hard for us to measure cloud cover over the entire Earth because it's constantly changing, whereas ice and snow remains more or less constant for a given season. The biggest contributors here are the ice sheets: Antarctica, Greenland, to a lesser extent the Arctic. Okay, clouds come and go, so we don't have quite as good a measurement on these as we'd like. Lastly, a big one is in aerosols from pollution and occasional volcanoes. So they can block out a significant amount of sunlight. We've seen this for very short periods when a major eruption occurs. I think the last major one was in the early 90s, and we saw a noticeable cooling overall on the Earth for about 2 or 3 years. America went through a little ice age, we say, around the time of the American Revolution, and we believe that extended cold winters were due to major eruptions around the world that coincided with that. Okay, so basically there's 4 things to look at if you want to understand why the climate would change. Only thing that has significantly changed in the last century of these 4 is the amount of greenhouse gases in our atmosphere, which have almost doubled. So if we're going to accept there's warming, this is the only explanation. There is no other physical phenomenon that could explain that. So if you're going to debate whether this is occurring or not, you have to address each of those 4. All right. Now, if there wasn't enough, you also have to consider what are called feedbacks. And I alluded to that earlier. These can confuse students, but basically a feedback is any temperature effect that is triggered by warming itself. So if we have some change in albedo, that might trigger another change which will make the warming even greater, or it might even trigger a cooling effect. So you have two types of feedbacks: a positive feedback, which would lead to more warming. Positive doesn't mean good or bad, it just simply means it increases the warming that's already occurring on top of what's already happening. And then a negative feedback would lead to a cooling effect, if you will, a brakes on the warming. Okay, so let's look at some significant feedbacks, because this is really maybe the most controversial part about the science for some people, and this is the linchpin for perhaps sending our temperatures into dangerous territories. Okay, because of more warming, you get more water vapor in the atmosphere. And water vapor is a major greenhouse gas. So we might have more warming due to a solar change or more CO2. That warming evaporates more water vapor in the atmosphere, creates more warming on top of that. It's not a runaway effect, it's more of a logarithmic effect, but it is something we must consider. Another major issue is, as the oceans warm, because of some physical factor, they release CO2. Okay, the oceans are a huge sink for carbon dioxide, so as they release CO2, then that's going to enhance the warming even more because of the greenhouse effect we alluded to earlier. Melting of ice sheets and glaciers because of warming temperatures decreases albedo. Not only does it decrease albedo, it exposes more liquid water, which is very good at absorbing radiation. So the warming due to the greenhouse effect decreases albedo, which increases the amount absorbed. Okay, thawing of the permafrost also releases more CO2. Clearing and burning of forests releases a lot of CO2, but it also increases albedo to a certain extent because of all the smoke. So that can have a neutral effect. So because of these positive feedbacks, and these are all very real, the warming is enhanced beyond the forcings, and that's critical. Okay, they're like magnifiers, if you will. Now, there are a few negative feedbacks. The major one is increased water vapor will also lead to more clouds, okay, which may increase albedo. So we have an increase. We've already talked about a decrease in albedo because of melting ice sheets and that, but there might be a break on that because of increased clouds. I don't know if the clouds are enough to offset this, and I think the jury's still out on that. If you put it all together, there's a net increase in energy input into the atmosphere of about 2 watts per square meter, and it is primarily due to CO2. Okay, so this chart below is a very important chart. I know it's not very large, but it looks at every single forcing that would make sense to change our climate, tries to quantify its effects in terms of this intensity, gives error bars in it, and we can see that the major contributions are greenhouse gases. There is some cooling effects due to aerosols, okay, and burning land or burning crops, etc. And so the net effect is right around here. That may not seem like a lot, but over the long term, it can have profound consequences. All right, I will stop here, answer questions about this tomorrow, and we'll look at then consequences of this warming.